It's battery test time. This time it's the Tenergy Premium Pro nickel metal hydride rechargeable battery with a claim capacity of 2800 milliamp hour and a 1200 cycle lifetime. It indicates on the box professional reliability for high-tech and smart devices. Nowhere on the box does it indicate that these are low self-discharge batteries, so we're going to put that to the test to see if in fact they are, or just kind of in that in-between state or not at all. The box has the usual notes on it. Really not much here aside from the fact that this pack comes with 12, and I forget what I paid for it. I'll put it up on the screen. There's not much in the box besides this little customer service card, and that's it. And then you get the 12 batteries as I roll them in from the side here. Here we go. The cells themselves are pretty good quality, but they do seem to look very similar to the EBL construction. They have a very similar pattern on the top as the EBLs do, and they have a different cover material. The EBLs seem like they use like I don't know what this material is, but it definitely is not as durable as this material. I've had a couple of EBL cells that I don't think I have out in here, but I'll cover it in a different video, but the caps have come off. The protective cover has come off because it just rips. But this seems like it's a more durable cell cover, and I say that as I look at one that's got a little bit of a rip on it. I've never had any other cells besides these EBLs and these do that. Anteloops, the variety of other cells that I'm testing at the moment do not have that issue. So interesting. Cell otherwise is, it just says Tenergy Corporation for Fremont, California, made in China, and then says Tenergy Premium Pro, rechargeable nickel metal hydride AA, 1.2 volt, 2800 milliamp hour, and that's it. So not much more to say about those besides let's look at some tests. It comes as a pack of 12. I tested 8 of the 12 batteries because I wanted to preserve my sanity, because there's a lot of testing to do. So I did 8 of the 12 cells randomly selected. So here they are. The 8 cells that were tested. The 8 cells that were tested, randomly selected from the 12. And here's the results. So we look at the capacity test results. They don't ever exceed 2.8 amp hour or 2800 milliamp hour, but that again wasn't really the expectation here. Just like these say that they are 2800 milliamp hour, and they did not come that close. Did not come close to it. The test profiles from the lowest discharge profile up to the highest discharge profile did remain pretty flat. That is quite good, and hovered basically around 2.6 amp hour. That's quite close to what they're claiming. It's about 92% of the claim capacity, so pretty close. And you know, that could be easily argued as well. It's plus or minus 10%, and they just, you know, these are all the minus 10% cells. Despite them not being 2800 milliamp hour capacity, the consistency in the capacity is pretty good. And if you look across the 8 cells for any particular discharge test profile, there's no cell that really falls super low. There are some that came out quite high, like especially in the first run with the 100 milliamp hour discharge current. There are some that were at 2.63 amp hour, 2.67. But as you get into the higher discharges, 500, 700, and 1000 milliamp hour, it's pretty consistent between the cells. You might have one or two that kind of popped up above the 2.6 amp hour, but still pretty much stayed around the same. So if we look at the graphs, you can see that there is some variance there, more than you'd see in perhaps some of the other cells that we've tested, with the exception of EBL and PowerOwl. But they're pretty consistent when it comes to capacity. Now, anybody who's watched this channel has seen that I've started to do 2 parts of the testing, which is capacity and then what is the internal impedance of the cell across multiple iterations. And so that's the second part of this, and that's where things get a little bit more interesting. This took 4 cells, randomly selected. I now forget which, I forgot to write them down. Oh, it was the 1st, 2nd, and the 7th, 8th cell. So they weren't randomly selected. They were specifically picked to get 2 cells from each of the 2 sets of 4. Here you can see that the internal impedance actually isn't super high. It's around 84.4 average. But the interesting thing comes with that lowest target current, the very first run, which is a 60 milliamp target current. And we see pretty high internal impedance. Cell 1 was 113.92. There is a lot of variation there in that first test profile. Still results in an impedance of 94.83 milliohms, but that's quite a bit higher than other cells that we've looked at. That includes like the IKEA lot of grays that, you know, at that lowest test current we're at 53.17 milliohms. That's over half. And that's the grays, that's the 2450s. And then the other graphs here, we got the individual battery internal impedance at specific loads. And there is quite a bit of variability there. It's not particularly smooth, and these are brand new cells. I don't think I mentioned at the top of the video, but these are, again, like everything else, they're charged and discharged 20 times. And then they go through a refresh cycle just to make sure that the cell gets a complete charge discharge and will be tested with its best foot forward, so to speak. And this is what we resulted in. So it's that first cell seems to be the one that really just, wasn't happy. And it kind of dances around there for the other cells. But the overall average battery internal impedance over the various loads it tested does show a pretty good linear curve there of about 0.7442, the R² value being about 0.7442. Yeah, you can see between that 240 and the 60 that nonlinearity starting to show up. You're not as concerned with the low self-discharge performance. These will serve just fine. They definitely perform better than, say, the Power Owls, based on what they were claiming the capacity was. The internal impedance measurements are a little bit concerning. They average out okay over if you're using them in higher discharge applications. And that's particularly why it seems like Tenergy is saying that basically use these in high discharge applications. So if you're buying these and putting them in computer mice, keyboards, I guess remote controls that take AA's, anything that's a low discharge device, these are not going to perform particularly well. So that's where you'd look for something like one of these 1900s that have lower capacity but better low self-discharge characteristic and will last longer than, say, something that has a higher capacity but higher self-discharge. They do come with a 1-year warranty. I've had these now for 6 months, and they're fine. None of them have conked out. None of them have showed behavior of suddenly not being able to accept the charge or showing very low retained capacity. This is the Tenergy Premium Pro nickel metal hydride rechargeable battery. Capacity 2800 milliamp hour, 1200 cycles, 12 pack. No mention on here about low self-discharge except on the web page on the Amazons that shows long-lasting power, and they say that it's 80% pre-charged, has 1200 life cycles, and that it retains 85% of its capacity after 1 year of storage. That seems more to me like that it's not trying to claim too much of a low self-discharge characteristic, but can maintain at least 85% after 1 year. Whether that's true or not, we'll see when we start looking at the really low current discharge. That'll be coming up after I finish the rest of these batteries. Hope you enjoyed this video. If you did, you know what to do. Like, subscribe, comment if you have any questions, and I will see you in the next one. Thanks for watching. Take care.